My Redstone computer writes something to the graphics memory as follows. Okay, to follow the Redstone more easily, let's tick freeze the game, input an A, and now let's step the game 4 ticks. The input from the keyboard is sent down here and is encoded to its binary value. The A is set to 20. On this Excel sheet here, you can see what I have set every value to, but let's concentrate on A here, and that's 20, and that's the binary code. Okay, let's continue stepping until we see some blinking down here. Okay, now, as you can see, it's a bit the order are actually 1, 2, 4, 8, 16, 20. Exactly what we wanted. Now the 20 enters the queue. The queue is for storing inputs before the CPU or the graphics card can do something with that. The graphics card and CPU only take an input every 4 seconds or so. I haven't calculated or tested that value perfectly, but it's something around 4 seconds or so. But on the keyboard, you can give an input every 4 game ticks or so. So this queue here is capable of accepting an input every 4 ticks. And it will always send the newest input to the top. Okay, let's continue that, and we see our 20 arrived now at the end of the queue. Okay, the display or the queue is set to display mode, so it will store the result onto the display memory. Okay, what is done therefore? The 20 is brought up here, and this activates this little clock here, which shows that there is something that wants to be printed on the display. Let's step another 4 ticks, and now a redstone signal arrived down here. This here is the counter that holds or stores where something should be stored. In which place. So there are 12 places, 12 segments where a character can be stored in. It starts by 0 because there is nothing on the display. And if I tick another 4 ticks, you can see the counter changes to 1. Now, if I step another 4 ticks, and 4 ticks more, this one is getting sent to the memory. I'm using here a rotary copper bulb memory, and yeah, basically just a quick explanation. There are many better videos on YouTube. By sending a signal to it, you can select which line should be selected, and then by pushing some pistons, it's like a big piston feed tape that where the values can be changed. Okay, let's continue the path of our redstone. Up here, our 20 is on its way. But first of all, the decoder down here now reacts to the 1, and because only the decoder for the first cell was tuned to 1, this redstone line here should turn off, and this here turns on, exactly. And if this redstone reaches this here, it sends a store signal. Now, there should also already be our 20 on its way. Exactly. Our 20 is now sent on the line on top here. And that is the actual line that is sending the input. Now go on. Let's go on. The 20 was now sent down here, and now activate these pistons down here. The stuff you have seen here looking up was actually for resetting this thing. The decoder here that detected the 1 has also sent an reset signal down here, which activates these pistons, and if a copper bulb is on, it activates this composter, which is filled to level 2. So only a power of 2 goes out here and deactivates this copper bulb. So this is resetted. Okay, our 20 is now stored in, was already down here in the observers, and now is put into the copper bulbs. And as you can see, the 20 arrived here. There are now some other things happening. For example, this here goes down, and this sends the freshly stored signal over the insta-wire to the GPU, and then prints it to segment 1. So if I fly quickly over here and now unfreeze the game, we should see an A coming up here. Okay, there is one last cool thing I still want to show about storing something into memory, and that is the delete function, or the delete button. It will delete the last entered character. And for that, it just stops here. If the delete function is activated, this line here is deactivated, and the program counter won't increase, and it will actually be decreased after the delete took place. And so the delete comes in, it's still on 1. Then on top here, an empty line sent. It's okay, actually for some logistical reasons, I chose delete to actually be an encoding. So this delete encoding that represents an empty pixel is sent, and after this that was sent, the program, not the program counter, the line counter is subtracted by 1. So if the next input comes, it will write to line 1 again. Exactly, and as you can see now, the delete worked, and you could now input something new. Another cool thing is that you can press write. So I do 2 times write, and now I set the line counter to 2, and by printing a V, the V should be printed to segment 3. Exactly. And the same thing is now possible with left. And now I can print an A. And this should give us an O. And what is better to end the video with something that isn't working? Yeah, exactly. I'm bad, of course. After the V, the next line would have been 4, that something would have been printed to. And then, yeah, I just came back from line 4 to line 3 with the left thing here. Okay, I already said the last thing. There is another cool thing, and that is that you can press desktop. That will deactivate to writing mode, and now I can use slash commands and I can press slash clear, and that will clear to currently enter, and that will clear the line that is currently displayed on the display. And as you can see, it was already cleared. And yeah, about this I already talked in another video, so I just give a quick explanation. Basically, this here is a little decoder that scans the input, and this thing here just checks, for example, by clear for a C. And if the C was detected, it goes to the next thing, and that is an L. And then if this L was detected, it goes to the next detector, and that's an E, and so on and so on. And at the end, it expects an enter. And if a wrong character is sent, so if slash C, and then for some reason you type M, this thing will detect the wrong input and will lock this unit until another slash is sent. Okay, I think now I really have talked about all functionalities of this display. There are some more coming from the CPU, like only activating one single pixel, but that's nothing for this video. Okay, bye, thank you for watching.